Hello everyone, I am Dion Chai Chu with a metric number of 77930. Today, I am going to make an experiment about the mixing series and parallel circuiting of resistors. As you all know, when the resistors are arranged in series, the current flows will be the same while the voltage across each resistor are different. On the other hand, when the resistors are in parallel arrangement, the voltage across each resistor are the same while the current flows will be different. Based on the schematic diagram here, the circuit consists of a 1.5 volt voltage source, 3 resistors with the same resistance value of 1 kilo ohm and connecting wires. There are a few test points to determine the partial voltage, partial current, total voltage and total current of the circuit. Partial voltage and partial current for each resistor can be determined by using the formula of current divider rule and voltage divider rule. For the first resistor, which is denoted as R1, the partial current is the same as the total current, whereas the partial voltage of R1 is determined by using the voltage divider rule of the total voltage. For the resistance R2, the partial current is determined by using the formula of the current divider rule of I23, which is the combination of the current of R2 and R3. The partial voltage of the resistor R2 is equivalent to the V23, which is the combination of the partial voltage of resistor R2 and R3. For the resistor R3, the partial current is determined by using the current divider rule of I23, whereas the partial voltage is the same as the resistor R2, which is equivalent to V23. So now I am going to construct a working circuit based on the schematic diagram shown below. Before constructing the working circuit, I want to introduce you about the elements that will be used in the circuit. Based on the schematic diagram shown below, the first resistor is in series with the parallel combination of the other two resistors. So now we take out a resistor to represent the first resistor. So this is connected in series, so it will be connected in a horizontal line like this. So for the second resistors, it will be in parallel with the third resistors, therefore it will connected in a vertical line. It will be direct use the vertical line of here, so connect into here. Okay. So for the third resistors, it will be connected in the same way as the second resistor. So we connect in here. Okay. Since the connection of the resistor is connected same as the schematic diagram, but they are still don't have a connection between the second resistors and the third resistors. So how do we connect between the two resistors? Yes, we need to use the jumper wire to connect among them. So the jumper wire will be direct connect from the second resistor connecting with the first resistors, and the line where the third resistor is connected on the breadboard. Okay, the lower side also need to be connected. Okay, after that, for a better illustration based on the schematic diagram, we need to connect one more jumper wire, as the same line with the second resistors, and here. So as you can see from the schematic diagram, the second resistors is directly connect to the voltage source. So how do we connect the battery into the circuit? So I will show you about the connection of the battery into the circuit. So for the battery, you can for the positive side, you need to connect it to the first resistor, which is here. And for the other side, it will be direct connect to the second resistor, the jumper wire connected to the second resistors. Okay. So now I am going to show you on the current flow in this working circuit. The current will flow through the positive terminal, which is this wire, through the first resistors, and then the current will be break into two, which will flow through the resistor 2 and resistor 3. Then after that, the current will combine again in this node and flows to the negative terminal, which is flows through this wire and this wire. So now we are going to measure the total current at test point AB and IJ. So where is the test point AB? So you need to break the connection here and connect in somewhere else on the breadboard. You connect here. So here is denoted as the test point AB. Then you need to use probe to connect here and here at the test point AB to determine the total current. So make sure you switch on the power supply now and switch on the multimeter and turn it to the current part. So the total current at test point AB is 1.091 milliampere. To determine the total current at test point IJ, you need to break the connection here and connect with somewhere here. So here is what we denote as test point IJ. After that, we need to use the probe and put it on here and here to determine the total current at test point IJ. Okay, let's open the power supply and switch on the multimeter. So the total current at test point IJ is determined as 1.091 milliampere. Okay, so as the same with just now, switch off the power supply and the multimeter first. So now I am going to determine the total voltage at test point BI. So I use the probe to put it on here and here, which is denoted as the test point BI. Before you begin to measure the total voltage, make sure you switch on the power supply and the multimeter before measuring the total voltage. The total voltage at test point BI is 1.684 volt. So now after measuring, make sure you switch off the power supply and the multimeter. Now I am going to determine the partial current and partial voltage at test point CD. To determine the test point CD, you need to break the connection of the resistor 1 and the resistor 2 and locate on here, in here. Here is how we known as test point CD. Then I will use a probe to put on here to determine the partial current at test point CD. Then switch on the power supply to determine the partial current and the multimeter and turn it into the current part. So the partial current at test point CD will be 1.091 milliampere. Okay, switch off the multimeter and the power supply for your safety. After that, connect back the resistor to the resistor 2. The partial voltage at test point CD, you can directly use the probe to connect to the resistor 1 connection. So to begin, you remember to switch on the power supply and the multimeter. The partial voltage at test point CD is 1.122 volt. To determine the partial current at test point EF, resistor 2 need to break connection and connect it in somewhere on the breadboard. Then use the probe to determine the partial current of test point EF. Remember to open the power supply and the multimeter. So the partial current at test point EF is 0.543 milliampere. After that, remember to switch off the multimeter and the power supply for your safety purpose. Then connect the resistor 2 back to the original place. Then for the partial voltage at test point EI, use the probe directly connect to the resistor for determining the partial voltage at test point EI. Then switch on the power supply again and the multimeter. Oh yeah. So the partial voltage at test point EI is 0.563 voltage. 0.563 volt. Then switch off the multimeter and power supply again. To determine the partial current at test point GH, we need to break down the resistor tree and connect it on somewhere here. Then use the probe and connect on the jumper wire here and the one on the resistor tree here. After that, switch on the power supply and the multimeter. Okay. So the partial current at test point GH is 0.548 milliampere. After that, switch off the multimeter and the power supply. Then connect back the resistor tree to the original place. On the other hand, for the partial voltage at test point GI, we directly use the probe and connect on the resistor tree. Then switch on the power supply and the multimeter. Okay. The partial voltage at test point GI is 0.563 volt. Then switch off again and the power supply. There are two tables which are current and voltage table. As a comparison, there is a differences between the measured and the theoretical values of voltage and current. For example, for the current table, the measured partial current at test point CD is 1.091 milliampere, while for the calculated partial current at test point CD is 1 milliampere. There is a difference of 0.091 milliampere between the measured and calculated partial current. On the other hand, the measured partial voltage at test point EI is 0.563 volt, whereas the calculated partial voltage at test point EI is 0.5 volt, where there is a differences of 0.063 volt between the measured and the calculated partial voltage. The difference between the measured and calculated value of partial current, partial voltage, total current, and total voltage at each test point is due to the systematic error in the multimeter, since there is an accuracy on the multimeter while measuring the voltage and current values. Therefore, this experiment concludes that the current and voltage values for each resistor are determined based on the arrangement of the resistor in the circuit. Besides that, the error is reduced by repeating the experiment for several times and obtain the average values of the current and voltage.